afternoon, everyone, and welcome to today's Masterclass episode. And we are honored to welcome Mr. Vivek Sonar, Head Material Cost Reduction for the Truck and Bus Division at Mahindra Rise, to today's MSME Masterclass. With over 38 years of experience in the automotive manufacturing sector, Mr. Sonar brings deep hands-on knowledge in new product development, process standardization, and cost-focused engineering. His extensive career covers the complete product life cycle, from concept and feasibility to production ramp-up and supplier collaboration. In his current role at Mahindra Rise, he leads material cost optimization efforts across commercial vehicle and bus product lines, ensuring products are not only functional and reliable but also financially viable. Mr. Sonar has played a pivotal role in aligning design and manufacturability, implementing stage gate development frameworks, and ensuring on-time within budget delivery. His practical experience in navigating real-world production challenges makes his perspective especially valuable for MSMEs seeking to scale product development while keeping costs under control. Today, he will share actionable insights and examples from his career to help MSMEs build better, more cost-effective products with long-term competitiveness in mind. Please join me in welcoming Mr. Vivek Sonar. Welcome, sir.
Thank you, Amrita, for a very nice introduction. And it's an honor and privilege to be part of this initiative. I would certainly try to do justice to the objective of this session, sharing my real life experiences, both in professional and personal lives, as much they fit into the objective of this session today. Thank you very much for inviting me.
Thank you so much, sir. So for attendees, I've already introduced the topic for today, which is cost-focused product development. And my first question to you, sir, is what are the most common cost drivers in early stage product design that MSMEs often overlook?
Good question. See, Amrita, in my close to 4 decades of working in the automotive industry, I have had an opportunity to work with wide range of suppliers, from micro to very large tier 1 companies, and some of which are sometimes bigger than the OEM by their market value. But my experience, to the point specifically with the micro and small suppliers, is the lack of understanding of the life cycle cost and of the any given project. And often the decisions are done by the small and micro, or to that extent MSME, only at a quote stage, only on the basis of very, I would say, superficial or very high level understanding of the project or product in question. And often they miss the entire life cycle, objectives or life cycle stages for managing that particular part. For example, there will be issues on supply chain, raw material supplies. If there are any special processes required by the design while manufacturing, availability of those special processes. There are issues to do with the raw material prices going, changes, raw material price changes which happen over a period of time, and the design changes which will keep coming as the design matures from a very, very early concept stage to series production. Now, all these dimensions are not considered largely by the MSMEs, and so the initial quotes are normally based on very high level specs, as I said, and there is no room for accommodating these changes, which puts a very huge pressure on them to deliver the product into the originally agreed target cost, and that stretches the entire value chain from them. That's my largely the answer to your question on which factors the MSME overlook.
And sir, if we have to define for MSMEs, how can they incorporate cost targets right from the concept stage without compromising on core functionality?
Good. Since you talk about right from concept stage, it means the MSME must get involved right at the concept stage with their customers or OEM or whoever is bringing that business to them, bringing their past learning, past experiences, dealing with similar kind of projects. Having that knowledge along with the industry knowledge, okay, is very, very critical for the MSME. Look, in the collaborative world today, the MSME should take that pride and position when discussing with their customers. Okay, there is nothing like bigger or smaller here. We all bring our own experiences, our own understandings, our own knowledge into the process, and it's only when both of them collaborate together the real value gets defined and delivered into the product. So the question on how can MSME incorporate cost target right at the concept stage, setting the cost target pretty early in the process helps. And as I said in the first question, taking into consideration all those factors. Okay, so cost target setting has to happen considering all those things. And for that matter, a simple cost sheet, Excel-based cost sheet, if that is developed by the MSME, keep it handy, which will consider right from raw material input to the process cost, to the overheads, to the profit margins and all other things. So there are various elements of the cost, which finally roll up into what is my affordable price for an MSME to quote. And in that process, since they have taken a 360-degree view of the cost, it becomes a better judgment than giving only on a superficial or high-level spec basis. So getting involved into the concept stage and going through the design maturity till it comes to the production stage, right? The design itself evolves. During the design phase, during the validation phase, during the prototyping phase, during the pre-production phase. So there are various stages the design matures. Now there has to be also scope and also provision for the MSME to look at what changes have happened from the original concept stage and how much of those changes are in our control, which needs to be appropriately adjusted into the cost target, how much are external factors. God forbid, if the world again goes back to the COVID era, that is what I was referring to, right? And provisions for these things must be done by the MSME rather than giving a quote on a high level basis. Target costing approach. So start analyzing what the customer is really willing to pay, what the product objectives are, okay, and what is my affordability, considering my profit margin is what basically, as a simple fundamental formula, I can. Thank you.
So there's a concept called as design-for-manufacturability. Can you help explain that, and can you tell our attendees why it's crucial in cost-focused development?
See, any design which is there in the question is aimed to be produced, to be manufactured in X numbers, okay, and to be sold to the end customer. So no design is made in the context here, which is to be kept in a drawing room or in a award library, right? So the moment we say the design is meant to deliver a physical product experience to the end customer, it has to go through the manufacturer. And the design for manufacturability, or generally it is called as DFM, is a very strong concept used by most of the new product development companies who deal with new product development, where at a very early stage, the relevant team members come together, the cross-functional team come together, and they look at the design and say, is it manufacturable? Yes or no? And if it is yes, does it call for any special tooling, special processes, special setup, special control? Yes or no? Now, when you go through the structured process, okay, asking those questions to the designer and also to the cross-functional team, and wherever the answers are negative, no, it cannot be done this way, it will call for a special, intervention. Either the design gets modified, or there has to be a cost and time resources consideration brought in for dealing with that special requirement. So design for manufacturability is a very, very powerful tool we follow in manufacturing in industry. But apart from that, I would like to add a couple of more points here. There is also a concept called design for assembly and design for service, apart from design for manufacturability. And design for assembly, as the name suggests, if the part is supposed to be a subset of the overall assembly, whether it is vehicle, whether it is any product, any structure, or anything you know comes to our mind, which means the part also has to be assembled to bring out the overall product. So the assembly friendliness of the design has to be also taken care. So one is manufacturing, then assembly. Last but not the least, if the product is serviceable, which means when the finished product goes into the hands of customer, it requires regular maintenance, it require regular servicing. How friendly the design is for the people who are servicing that product. And I'll give one example in my very early stage of my career, where there was a beautiful bus body was designed on a chassis of a vehicle. And when the vehicle was brought to us for show and tell, all of us were going around the bus and we were amazed with the style, with the color, with the contour and overall aesthetic of the bus. And suddenly, in that process, one mechanic standing next to me asked me, I know, do you have a car for you? Yes. So there is a radiator in the car, right? Which contains water. And at a regular frequency, generally the driver will open the bonnet, open the cap, check the water level. If not, add the water level. And that's a part of very, very routine touch point for the driver.
Yeah.
Unfortunately, the provision for accessing the radiator cap in the front shop of the vehicle was not given. Which means what? If I have to check the radiator water level, I have to take out the entire bus body from the vehicle, which cannot be done by the normal customer, right?
Correct.
No, it's such a simple thing was not thought through. And the provisions were not made in the front show of the bus for the daily touch point. Now, this tells me, and this example I'm quoting almost like 35, 36 years before. Okay, and it was a mistake which was immediately corrected. But such mistakes, any correction calls for extra efforts, extra cost, and all those things. So the design for manufacturability, design for assembly, and design for service structurally help the team and should help the MSME, to take into account how the design will move from a drawing board to mass production and in the hands of customer for the life cycle.
Got it, sir. So there are a couple of checkpoints or stage practices that MSMEs can adopt to monitor and control products through cost through development. Can you tell us what are these stage gate practices or checkpoints?
So as I was explaining in the previous question, a design concept is born at a very early stage in any product development life cycle. And the design goes through a series of evolution. First in the virtual form on a computer. Then it is released for prototyping. So some physical touch and point, physical checks to be done, the design is released to prototyping. And after the prototyping, it matures further to a pre-production and production stage before it goes into final manufacturing or final production, right? So world over, the new product development process follows certain stage gates. And those stage gates are also applied to the MSME. Because in earlier question, we discussed about MSME must get integrated at a concept stage. So if I take that as the first gate, then there are certain gates which I would propose to MSME to be involved. One is concept, followed by a design gate, where the detailed design happens. And the design is evaluated in a virtual manner on a computer. So that is the design stage. Then there is a prototype stage, where physical prototypes are made for limited level of verification and validation. Once that is done, then you go and do a limited tooling investment to make a tooled up product, which is where the pre-production stage comes. Okay, and post that there is the production stage. So there are 4-5 stages I would recommend as a checkpoint or as a gate. Is the concept gate, design gate, prototype gate, pre-production gate, and a product SOVP gate or production gate. SOVP is start of volume production. So these 5-6 stages MSME must adopt in their ecosystem also to monitor how the design is evolving, what are all the new specifications, changes are getting added, okay, and how that impacts on the product cost as well as development cost.
Got it, sir. So moving on, can you tell our attendees how can they balance material selection with durability and cost in industrial components?
Amruta, I don't think that should be the very concern for an MSME, because looking at the way the entire manufacturing industry has evolved over last so many decades, when it comes to balancing the material selection, I mean, the database and the knowledge base is pretty matured in that case. There are raw material standards. There are Indian standard. There are international standards. For example, if I talk about steel, then there is an IS 1079 for HRC or IS 513 for cold rolled steel or 1239 for steel tubes. These standards are available in the ecosystem. This standard guide the user to select a right material grade for the product or for the objective in hand. Now, these standards will also have material specification, grades, any special treatment, strength, durability, performance. All those parameters can be evaluated using these particular standards. So, and as I said, these standards also give you a flavor of what the cost would be. So in a lower range, if you pick up an EN8 material, we know in the market what it costs per kg, as against any high-end material with special treatment, gold plating, silver plating, or even zinc plating, what it calls for. So a balancing between selecting a right material and looking at the associated cost impact is pretty mature practice in the industry, but MSME must make a conscious effort to refer the standard, use their experiences. One of the pitfalls which I have seen is generally when the customer gives the requirement, I need a part in this material, MSME generally take that as the gospel truth, and then they struggle to make that part in the given cost target. And here my request to MSME would be, use your experience, use your part library, use your knowledge, industry knowledge on this. You can also propose, sir, instead of that material, can I use this material? It's a better, we have used it earlier. We have been supplying this part and this material for that purpose. It is also performing. It is also that healthy dialogue using those historical experiences and data points must be encouraged. And I would urge MSME to take that step forward and discuss with their customers, so that at the end of the day, keeping the end objective in the mind, keeping the end objectives related to quality, performance, durability, and cost are made in a most frugal way.
Got it. Understood, sir. So now tell us, what role do supplier involvement play during early stages in design and driving down development costs?
So this is regarding development cost, right? Good. Many of the automobile OEMs, they follow a concept called as ESI, which is early supplier involvement. Now, just to give you a point of view, if you take any car on the road, a car would generally consist of the smallest to the biggest by size, by volume, by weight parts, close to about 2,500 to 3,000 parts. Okay, and as I was discussing earlier with you, roughly about 70 to 80% of those parts are related to steel, one or other form of steel, metal for that matter. Okay? And roughly there is also a concept called as some of the designs are owned by the OEMs or by the customers, and some designs are given by the suppliers. So if I bring in a terminology called build to print, build to design, okay, and a system supply, which the ownership right is with the supplier, with the MSC, right? Close to about 60-70% of the content of those 3,000 parts on the car is supplier owned. What it tells us that the supplier must get involved very early in this stage. The early supplier involvement calls for the MSME, concerned MSME, and the OEM or the customer sit together in an automobile context, and I'm sure it is applicable for the other sectors also under manufacturing. They must sit together early engagement, and right at the concept stage, right when the designer is saying, I want a part to, for this particular purpose. Now, many times what I have seen pitfalls again here happening is the end objective, what it is serving, the end function, what the part is supposed to do, deliver to the end user, who is neither the maker nor the checker nor the MSME. The customer is somebody else. Now, have you really understood what is this requirement? Have we really understood what exactly he or she, that customer, is finally expecting? And how do we translate that requirement into the design? And I don't know whether you have heard this example, but this is a very famous example quoted on internet for long, that a washing machine company suddenly launched a new product and suddenly started getting complaints of washing machine failure from a particular state of India. They were surprised why it is happening. So a team goes there, does the investigation, on-site investigation. To their astonishment, they realize it was a washing machine. It's supposed to be used for washing clothes, but in that particular region, it was made for making lassi. You can imagine the part which was designed to handle some chemicals which are there in the washing soda or washing liquid and the fabric of the cloth is suddenly being subjected to some other use, which is not intended. Now here, though it is a joke or it may be a fiction story, but what it tells us that the end objective, the end usage of the customer must be understood by both the MSME and the customer, their customer or their OE organization. And that's where the early supplier involvement is must, because otherwise it becomes 7 blind and 1 elephant story, right? So we need everybody to come together, look at that elephant, which is the part in question, see it from all sides, okay? Bring our experiences together, and then take the further steps. That is where I would suggest you and the MSME, the role they have to play is a very prominent role, very forward role. It is not submissive role, it's more a proactive role. And it's a collaborative role between the MSME and their customer or their OEMs.
Now, sir, can you please help and share some examples where early supplier integration led to significant cost savings?
Most certainly. I mean, there are several examples. Like if I talk about automotive industry, there are suspension parts, car suspension, if I can check, or there are the cabin part, the car body part, which primarily consume steel, very high amount of steel. Now there, the joint collaboration between the suppliers and the OEM has actually helped us from the original thought process of the cost of the product has helped us to reduce close to about 30% of the cost during the development, because here, and thankfully here, the suppliers played a major role in telling our designers, with an alternative solution, with the alternative suggestions, using library parts, using proven standard material and processes, right? Bringing in cross-industry experiences, bringing in cross-industry use cases for that matter, and it has helped reduce the substantially the cost of the product.
So tell us, there are modular design considerations and approaches that we've seen and heard of. Can you tell our attendees how can these modular design approaches help MSMEs reduce both design and production costs?
Again, if you look at any industrial example, a sub-assembly, or the product is made of multiple components. Now, if on one hand, if you try to imagine that each part is unique in itself, it's not previously being designed or developed or delivered by anybody, and I'm trying to do it, every single part, okay, as a unique part. Now, imagine what it means for the maker, who is the MSME here. They have to maintain, right from maintaining the standards, maintaining the drawing, maintaining the record, raw material procurement, processing, production processing, checking, fixturing, gauging, tooling, which is development cost intensive, and maintaining a life cycle, inventory of all these parts, including the supply chain management, the logistic management, the packaging management, the storage management, everything is involved. Now, if you have such unique parts, series of unique parts, you mean you are actually having series of lines or series of machines or series of units to deal with those. As against, take an example of Lego toys, take an example of IKEA for that matter. That concept tells us that you keep the basic things same, try and add the variety on a peripheral. For example, if I take an example of a car chassis, right? How can I make the chassis generally made up of two long members, and there are in between cross connections, which we call cross members. So a typical car chassis will have two long members for sure, and multiple cross member. They can be, depending on the length of the car, they can be in 4 number, 5 number, 6 number. Now, if I design every cross member differently, then it is as much of development cost, development effort, development resources, development time, and its associated burden on the product cost. As against, if I keep the center portion of the cross member of same section, same material, same size, and just change the end gusset, we call the end connection with the long member, and make them small part, modular part, I can create many varieties out of that, right? So the modular design approach is actually a very good concept. We must, leverage to its fullest potential, because it reduces it actually takes out the entire complexity of the life cycle of the product. It brings in, a lot of simplicity, and more simplicity mean lesser cost, lesser development, lesser product cost, right? So, like a furniture manufacturer, I was telling you, right? The modular design helps contain both the investment cost and the product cost. The key characteristics of any modular design is into breaking down the entire product into smaller, manageable, functional modules, having a high level of standardization, both in terms of the material uses and also the production processes. Okay, and that balance must be stricken off at very early stage in the design. Because if I talk again from automotive industry, you would have seen a car model is same, but it has got multiple variants. There is a lower end variant without AC, without power window. At a higher end, you have sunroof, you have automated switches, you have sunroof, and you have AC and other all high-end features coming. Now, that's the only difference in the trim parts or feature part the company generally, put in. but the base car remains same. That's a different level of modularity concept, is what I am trying to explain here.
Got it. Got it. So my next question to you is, how do we ensure that cost reduction efforts don't compromise product quality or customer requirements?
Good question. I was expecting that to come, Amrita. See, cost reduction obviously cannot happen at the cost of degrading the quality or defeating the quality. The quality as a broader umbrella term is in the core. The very reason both the parties, MSME and the OEs, are coming together and discussing, because there is an objective in hand. And that quality objective is, I need this part to be fitted in this particular vehicle or larger structure, and this has to survive 1, 2, 3, 4, 5 and deliver the objective, deliver a set defined value to the customer. Now that is at the center, and the cost is getting built around it. To give you a very specific example, if I'm hungry, what are the options I have? At a lower end, okay, since we are closer to Mumbai, Maharashtra here, a vada pav will do, right? Or at a higher end, I can always go to the 7-star hotel and look for a 5-course or 7-course meal. Absolutely. And in between there will be various options, right? Now, what is desire? What is the objective here? My objective is my hunger. Is it a one-time meal, or I have to sustain it for my lifetime? My decisions to go for vada pav or go for a 7-course, 7-star hotel meal is deciding this. It is influenced by this. It's the same here. So here I would like to propose to MSME that rather than focusing on cost, something to be reduced, something to be optimized, change the focus to value. Okay? There are various tools and techniques, proven methodology available as value methodology or value engineering. What is value engineering? It takes the center stage, objective takes the center stage for it. The quality, what is required to be done, takes a center stage. And then cost is built around it, evaluating various frugal options available. Rather than taking cost as my center stage and build the quality around it. It should be other way around, right? Balancing value versus cost, balancing functions to be delivered is an approach I would request the MSME should take. And practicing value engineering methodology, practicing value engineering techniques would help them orient them and their team members to deliver the product at the most optimized cost. And when I say cost, it is for everything, for the resources, for their factory, for their labor, everything goes into it, right? So cost is not just in the raw material I am procuring. Cost is in every aspect. So shifting focus from managing cost to delivering value at a most frugal way, in a most frugal way, should be my advice to the MSME.
So now tell us, according to you, what are the best cost benchmarking tools or techniques that MSMEs can use during product planning phase?
There are various standard methods of deciding what should be the target cost and how the cost should evolve over a period of time. Proven techniques like something called as should be cost, or it is the acronym is SBC, should be cost. Now, as the English says, should be costing. This part, how much it should cost, if made as defined in the drawing, as specified in the drawing, what it should cost, right? Or there is other tool, there is something called a ZBC, zero-based cost, which means you start from ground zero and then you start building the cost layer by layer, first dealing with the raw material, then dealing with the processes, then dealing with the tool and all other elements, and build by parameter that cost and arrive at the higher level cost or the final cost. So should be costing, zero-based costing are two very powerful tools today practiced by most of the people in manufacturing industry. There is something called as competitive benchmarking. Say, one life is very inadequate for all of us to learn everything and anything we want to know. Okay? And we must also be humble enough to accept that there are more smarter, more knowledgeable people around the world doing the same business. So there is no harm in going and looking at how others have done and take some inspiration. It's not crime, right? So competitive benchmarking, how others are doing, not just in same industry, but also in parallel industry or unparalleled industry. Competitive benchmarking is another tool where the MSMEs can very leverage for at a very early stage when they are talking about deciding target costing and then the associated elements in the product planning. And there are as I was earlier saying, there are cost sheets, Excel-based simple cost sheet. If you make, I have seen the many MSMEs I have worked with, they even don't maintain a simple Excel-based line item wise cost sheet with them. The cost generally done here by the experienced person, either by the owner or the proprietor. And while I don't want to disrespect any particular section of the society, they may have their experience speaking for themselves, and that is right? But is it adequate for me to hold on to that view throughout the life cycle, from the concept to production and thereafter? And there it has its own challenges. So it is good to have things documented, things arranged organized in a structured manner, like a cost sheet I am saying, and then put these tools like should be costing, zero-based costing, or competitive benchmarking, okay, to fine tune the cost which are getting into these development.
With that, we've come to the end of today's episode. So thank you so much for sharing your detailed insights on such a critical and important topic for our MSMEs, which is cost-focused product development. I am 100% sure that with your almost 4 decades of experience in this field, they will gain a lot of insights and intel into this particular subject. Thank you so much, sir.
Thank you, Amruta. I really appreciate for that opportunity and sharing my own experiences with the MSME. Touch wood, I'm sure they will find some value into this entire discussion, which will help them do better, be better, and be efficient. Thank you and good luck.
Thank you so much once again, sir. For our attendees who are online, if you'd like to view the current episode, if you've missed any part of the current episode, please go on YouTube, type GSW1 MSME, and you will find all our episodes uploaded there. Thank you once again, sir. Bye-bye.
Thank you. Bye-bye.